Today we are going to be looking at question 11 of the Wassce 2010 May-June General Mathematics question. It says, in the diagram, angle PTQ equals angle PSR, which is equal to 90 degrees. That means these angles right here are 90 degrees. They are right angle triangle. Line PQ equals 10 centimeters. Line PQ, this is PQ right here, okay, equals 10 centimeters, okay, and line PS equals 14.4 centimeters. Line PS is from here, 14.4 centimeters, okay, to here, right? PS, okay. Now, and line TQ is 6 centimeters. TQ is right here, 6 centimeters. That's from here, okay, to here. Very good. Calculate the area of quadrilateral QRST. QRST. Very good. We want to calculate the area of quadrilateral QRST. Now, the first thing you need to know right here is what shape is this quadrilateral QRST? QRST. You first of all need to know that that shape is a trapezium. It's a trapezium, okay? So that means I have area of the quadrilateral QR quadrilateral QRST, okay, would be equals to area of trapezium. Will be equals to area of trapezium, okay. That is the first thing you need to know. And then what is the area of trapezium? I'll give it to you right here real quick before we go ahead. So the area of trapezium will be equals to half times the sum of the two parallel sides of the two parallel sides, okay, times the height. Area of trapezium is half times the sum of the two parallel sides times the height. Okay, now so that means in that case we need to know the parallel sides. So this is QRST, okay? This is one of the parallel sides and this is the other side. So we know this side to be 6. We do not know this side, which is SR, and the height is going to be TS. We don't know this side. So that means we need to find line TS and also SR before we can be able to find the area of trapezium. Okay, let's go on with this journey right now, guys. So now, one thing you need to also look at right here is, if you take a look at this triangle PTQ, triangle PTQ is a right angle triangle. PQ is the hypotenuse, PT is the opposite, and TQ is the adjacent. So let us calculate PT. If I can calculate PT, I should be able to get TS, okay? Now, very good, guys. So let us calculate. Let us now calculate PT, okay? So using Pythagoras theorem, okay, I will have line PQ squared equals, that's the hypotenuse, equals to line PT, okay, squared, plus line TQ squared, okay. Now line PQ is 10 centimeters and TQ is 6 centimeters. Very good. Let us go ahead. So PQ, we said, is 10 centimeters, then you put square, equals PT, that is what we are looking for, squared, plus TQ, we said that is 6, okay, then you put square, okay. Now what do we do? This is 10 squared is going to give you 100 equals PT squared plus 6 squared is 36, okay. Now if you collect like terms, what do you have? Plus 30, positive 36 go to the other side to become negative 36 equals line PT squared, okay. So that means line PT squared is going to give us 100 minus 36. That is going to give us 64. Very good, guys. That's going to give us 64. Now, to find PT, because this is square, right? What do you need to do? You take square root of both sides, okay? So you take square root of both sides. So if you take square root of PT, that's going to give you PT right there, okay? And then here you have square root of 64, okay. Square root of PT squared is going to give you PT, right? And then you have square root of 64. So in that case, PT is going to give you what? Square root of 64, that is 8. That is it. Very good. That means PT is 8 centimeters. Very good, guys. Let's go back to the diagram again to see what we have done. So that means we have been able to calculate PT right here. We have been able to calculate PT right here. And we said PT, we just calculated, is 8 centimeters. Very good. So that means if you take a look at this, we said from here to here, that's PS, is 14.4 centimeters. From here to here, that's P to T, is 8 centimeters. What is going to be from here to here? You would agree with me that that is going to be subtraction. That's going to be 14.4 minus 8 is going to give you TS, right? It's going to give you line TS. So that means I will come right here and I will say line TS, okay, equals to 14.4 centimeters minus PT, okay. Now we just got PT, which is 8 centimeters. So that means TS is equal to 6.4 centimeters. Very good, guys. Very good. We've been able to get TS to be 6.4 centimeters. So now I have here to be 6.4 centimeters. Very good. So now if you go back to your to the formula for area of trapezium, we've been able to get the height of the trapezium. We've been able to get the height of the trapezium, which is 6.4. We said here is sum of the two parallel sides. We've only gotten one. Now we need to get this side, which is RS. So now here your knowledge of similar triangles is highly needed right here. Is highly needed right here, because you would agree that we have these similar triangles right here. This is a triangle, and triangle PTQ, triangle PTQ, and also another triangle is triangle PSR. You have triangle PTQ and triangle PSR. Okay, so that means I can say consider similar triangles PTQ, and PSR. Take note, these are two similar triangles, PTQ and PSR. Okay, now how do we solve that? Now a way to solve that is you can say PT, which is 8/6. You can say 8/6, okay, that's for this smaller triangle, equals to 14.4 over SR. You will take note of what I'm doing because it's similar triangles. I'm considering the same of both, the same size of both triangle. I'm considering this side, I'm considering this one, I'm considering this side, I'm also considering this side right here. So it's going to be 8/6 equals to 14.4 over SR. Okay, so that's similar triangles right there. So WAEC needs your knowledge of similar triangles. Okay, so now I'm going to say 8/6 equals to 14.4 over line SR. Okay, because they have similar triangles, triangles PTQ and PSR. Okay, so now what you can do right here is to cross multiply. Okay, I can have this right here, I can also have this right here. So that means that I can have 8 times line SR, okay, equals to 6 times 14.4. Okay, now what am I looking for? I'm looking for SR, right? So I can divide both sides by 8. So if I divide both sides by 8, this is going to give me divided by 8 divided by 8. Okay, 8 cancels 8. So I have line SR equals to 6 times 14.4, and then you divide it by 8. If you use a calculator, your answer is going to be 10.8 centimeters. So that means my line SR is 10.8 centimeters. Very good, guys, very good. That means we have been able to get this side right now, which is 10.8 centimeters. Very good. And you remember area of trapezium, half bracket sum of the two parallel sides. So now we have the two parallel sides, okay, times height. We also have our height right here. Okay, so now we can find the area of the quadrilateral QRST, which is the area of our trapezium QRST. Okay, so I can come here now and say area of trapezium, or you say quadrilateral QRST. Okay, that's going to be equals to half bracket the two sides that we have are 6 plus 10.8, okay, times the height, which we also got before, 6.5. okay, so that's going to give us half bracket is times 6 plus 10.8 16.8, okay, times 6.4. So if you multiply your numerators and divide by 2, you should be having 53.76, because this is area, is going to be centimeter square, because you have the unit is centimeters and it is area is going to be centimeter square. Very good, guys. I hope you understand this solution, because the area we are looking for is trapezium, and we were able to get, and the formula for the trapezium is half times the sum of the two parallel sides times the height. Okay, so what we did first was to get the height and also the other parallel sides, and then we applied the formula. Very good, guys, very good. Now let us take a look at the question B of number 11. Okay, it says that two opposite sides of a square are each decreased by 10%, while the other two are each increased by 15% to form a rectangle. Find the ratio of the area of the rectangle to that of the square. The first thing you want to do right here is to draw your square. Take note, guys, this is a freehand sketch. It's not going to be as good as you would imagine. This is square, okay? Okay. Two opposite sides of a square. Now we know that a square has all its sides equal. Okay, so I will take all the sides of my square to be L. They are all size L. Okay, this is my square. So two opposite sides of a square are each decreased by 10%. Two opposite sides of a square are each decreased by 10%. That means that I would say these two opposite sides, okay, these are decreased by 10%. Okay, so now this is what we are having right here. So we can say if first opposite sides, okay, were decreased, okay, by 10%. What does that mean? These are the first two opposite sides we are talking about. You decrease them by 10%. Okay, so if you decrease them by 10%, what does that mean? How many is going to remain? So that means it's going to remain. That means we can say the new length of that will be 90% of L. It's going to be 90% of the length, right? Why did we say that? We were told that these two opposite sides, that is their length, are each decreased by 10%. Okay, if first opposite sides were decreased by 10%, so if you decrease them by 10%, that means you'll be left with 90%, right? Because percent is 100, right? So 100 minus 10 is 90. So you'll be left with 90% of L. Okay, so let's move on with that. 90% means 90 over 100. Of means times. Then we have L right there. Okay, now what do we have right here? 90 over 100. You agree with me that that is 0.9. Okay, so that is 0.9 times L. That's 0.9 L. So that means for this to have been decreased, That means they are decreased from L, so now you have 0.9 L. Okay, now the second part, stay with me guys with this is easy. And it says while the other two are each increased by 15% to form a rectangle, we have decreased one part by 10%, right? That means the remaining is 0.9, and the other two are increased by 15%. Let us analyze that one right now. Okay, so we can say other two sides were increased, okay, were increased by 15%. Other two sides were increased by 50%, okay? So now if they were increased by 15%, what does that mean? It means that the new length, of these other two sides we are talking about, it means the new length is 115% of L. Okay, so this is what we are saying right here. These other two parts, these are increased by 15%. Okay, before it was a full length 100%. Now you increased it by 15%. What is that going to be? It's now going to be 115%. Okay, so what we have here is these two sides, what we have right here is these two sides right here, and these were decreased by 10%, right? So we got the new length to be 90% of L, which is 0.9 L. But this one, these other two sides were increased by 15%. If they were increased by 15%, means that their new length is now 115%, because it's going to be 100 plus 15, okay, 115%, okay, which is going to be 115 divided by 100 times L, okay, and which in that case 115 over 100 is 1.15, okay, times L, 1.15 L. Very good guys, very good. We are almost there. Now let us go back to the question. The question now says find the ratio of the area of the rectangle to that of the square. Remember, we started from being a square. All the lengths are L, right? But now two of the sides, this side and this side, have been decreased, right? Now it is 0.9 L. Let us draw that out. So now this is what I have right here. This side they were decreased. Now I have 0.9 L, okay, 0.9 L, okay, and these other sides of the square, this side and this side were increased by 15%, okay. Because they were increased by 15%, we said now it is 1.15 L. So now I have 1.15 L, okay, 1.15 L. Now the question now says we should find the ratio of the area of rectangle to that of square, okay. So now that is where we are at. we will say that ratio of area of rectangle, okay, to that of the area of square. That is what the question asked us, right? And we know that the area of rectangle is length times the breadth, okay, over the area of a square is L squared, because all the sides are equal, okay. For rectangle, all the sides are not equal. So what do we have for rectangle? This is the length. This is the length from here to here, and that is 1.15 L, okay, times the breadth is from here, or the width is from here to here, okay. So that is going to be 0.9 L. Very good, guys. Divided by the area of the square is L squared. L squared. We know this is L, right? L squared, because all the sides of a square are the same. Because even it comes from the fact that you say length times breadth or length times width in a square, but because they are all the same, L times L is L squared, right? It's L squared. So we will put L squared right there, okay. Now let us simplify, okay. 1.15 L times 0.9 squared, what will that give us? That's going to give 1.15 L times 0.9 L, rather, that's going to give us 1.035 L squared, okay, over L squared right here, okay. Now if you take a look at this, what will this give us right here? This would give us L squared, cancel L squared, L squared 1, L squared 1, right? So that means my final answer right here gives me 1.035 over 1. Can you see that, guys? 1.035 over 1, okay? So that tells me, and remember that we are talking about ratio, that tells me that the ratio of area of rectangle to area of a square is 1.035 ratio 1. So I can conclude by saying, therefore, ratio of area, okay, of rectangle, okay, to area of square equals to, because area of rectangle is the one at the top, that's 1.035. very good. Then this division sign, this over, is the ratio sign, okay. And what do you have here? 1, which is from here, which is 1. So your final answer is 1.035 ratio 1. Very good, guys. I hope you understand that solution. Very good. Some other people would like to convert this ratio to a whole number, because this is in decimal, right? Although if you put this as your final answer, you are definitely correct, okay. But if you want to go a step higher, you could convert your decimal into whole number. And for you to do that, all you have to do is you have to look for a number, okay, that when you multiply both of these numbers by, is going to give you a whole number. And a good number for you to do that is multiply 1.035 by 200, okay, and also multiply 1 by 200. So if you multiply both of them by 200, you are going to arrive at 207 ratio 200, because 200 times 1.035 will give you 207. 1 times 200 will give you 200. This is also your final answer. So you can leave your answer this way, or you can leave it this way. Both are correct answers. Like I said, that because this one is in decimal, you may want to go a little bit higher by converting it to a whole number. For you to do that, you have to multiply both this number 1.035 and 1 by a number that will convert both of them, or that will change both of them to a whole number. And 200 seems to be the smallest number you can use right here to convert to a whole number. So this is your final answer, or this is also your final answer. Alright guys, I will see you in the next class.